The search for another Earth. Imagine looking up at the night sky. Billions of stars shine. Are there other planets like our Earth out there? Could there be life? This is a big question. Scientists around the world are trying to find answers. They are looking for planets outside our own family of planets, our solar system. These are called exoplanets. Finding any exoplanet is exciting, but scientists are most interested in finding planets that are like Earth. Planets where life, like we know it, might exist. This search is a careful job. It needs a lot of thinking. Let's follow Dr. Evelyn Reed, a scientist. She looks at data from space telescopes. She is part of this great search. What makes a planet Earth-like? Dr. Reed sits in her quiet office. Screens glow with numbers and charts. Not every planet can be like Earth, she thinks. We need to look for specific things. First, size. The planet needs to be rocky, like Earth, not a giant ball of gas like Jupiter. If it's too small, it might not have enough gravity to hold air, an atmosphere, so size is important. It must be about the size of Earth. Second, location. The planet needs to be in the right place around its star. This place is called the Habitable Zone. Dr. Reed calls it the Goldilocks Zone. Why? Because it must be just right. Not too hot, or water boils away. Not too cold, or water freezes solid. It needs to be the right temperature for liquid water. Scientists believe liquid water is needed for life. The habitable zone is different for every star. Bigger, hotter stars have zones farther away. Smaller, cooler stars have zones closer in. Third, the star. The planet needs a good parent star. The star should be stable. It should not shoot out too much dangerous energy, like big flares. These flares could harm life. Also, the star needs to be old enough. Life takes a long time to start and grow. Many common stars, called red dwarfs, have planets in their habitable zones. But red dwarfs can sometimes have strong flares. So, scientists must check the star carefully. Fourth, air. The planet probably needs an atmosphere. Air helps keep the planet warm. It protects the surface from harmful rays from space. It might hold gases that life needs, like oxygen. Finding out if a planet has air is very important. How do scientists find these planets? Dr. Reed looks at new data. It comes from a space telescope called TESS. TESS watches thousands of stars. It looks for tiny dips in a star's brightness. Here is one. Dr. Reed whispers. She points to a graph. This star dimmed just a little, then again and again, regularly. This is the transit method. It means a planet might be passing in front of its star, blocking a tiny bit of light. TESS is good at finding planets this way, especially around stars close to us. TESS finds many possible planets. They are called TESS Objects of Interest, or Dr. Reed checks the data for a toy. Let's call it TOI999b. Okay, she thinks. The dip tells us the planet's size. Yes, it looks rocky. Good. The time between dips tells us how long it takes to go around the star. Okay, it seems to be in the habitable zone. This is exciting, but Dr. Reed knows this is just the start. This is where critical thinking is very important. Is it really habitable? She asks herself. TESS tells us the size and the location, but it doesn't tell us about the air. It doesn't tell us if the star is quiet. The next step, looking closer with JWST. For the next step, scientists need a different tool, a very powerful space telescope called the James Webb Space Telescope, or JWST. JWST is special. It can study the light that passes through a planet's atmosphere during a transit. Imagine the starlight shining through the air of TOI999b. Different gases in the air absorb different colors of light. JWST can see these missing colors. It's like a fingerprint for the air. With JWST, Dr. Reed explains, we can look for the fingerprint of water. We can look for carbon dioxide. We can look for methane. And the biggest goal, looking for biosignatures. These are signs of life. For example, finding oxygen and methane together in an atmosphere could be a strong sign of life. It's hard to have both gases without life making them. Many candidates, much work to do. The search has found many interesting planets. There is the TRAPPIST-1 system. It has 7 Earth-sized planets around a small red dwarf star. Some are in the habitable zone. JWST is studying them right now. There is Proxima Centauri b, the closest exoplanet, but its star flares a lot. TESS keeps finding more candidates, like TOI 700d and E, or Wolf 1069b. Dr. Reed looks at the TOI999b file again. It's a good candidate, but candidate is the important word. It means possible. It meets some basic rules. But does it have water? Does it have air? Is there life? We don't know yet. Finding another Earth takes time. It takes powerful telescopes like TESS and JWST, and it takes careful critical thinking by scientists like Dr. Evelyn Reed. They look at the data, they ask hard questions, they check everything. The search continues, star by star, planet by planet. Maybe, one day, we will find we are not alone.